The world is round and it moves. Once it meant death or imprisonment to say this. Now these facts are the first which we learn about the earth. Let us begin with them and examine our world in a little more detail. First, consider the axis about which the earth rotates. This is called the north-south axis. This end is the North Pole, and this the South Pole. Now, the earth is not a perfect sphere, but is slightly flattened at the north and south poles. This flattening at the poles is taken into consideration when the various navigational tables are computed. But in our studies, we shall consider that the earth is a sphere, that is, perfectly round. After all, the difference in nautical miles between this diameter and this diameter is only about 24 miles. We pass a plane through the earth so that it intersects the midpoint of the axis, O, which is also the center of the earth. The line formed where it cuts the surface is called a great circle. Moving the plane of a great circle so that it is at right angles or 90 degrees to the axis, we have a special great circle. It is called the equator. Because the plane of the equator is perpendicular to the axis, all points on the equator are the same distance from the poles. Let us consider a position B. In moving from the equator to B, we travel a certain distance north on the Earth's surface. As we assume the Earth a sphere, this distance, AB, is an arc of a circle. It is measured by an angle L at the center of the Earth, O. The angle L is a measure of the latitude. Therefore, B is at a point latitude L degrees north of the equator. The arc AB is equal to the angle L, and therefore is also a measure of the latitude of B. Note that if we are in latitude L degrees north, our position can be anywhere along a line that extends all the way around the Earth parallel to the equator. This line is called a parallel of latitude. Note that the planes of the parallels are parallel to the plane of the equator, but that no parallel is a great circle because its plane does not pass through the center of the Earth. Parallels are called small circles. When they appear on a globe of the world, it is convenient to show these parallels separated by a uniform distance, such as 10 degrees. Any position on the Earth is defined by two coordinates. This one, latitude, is measured by the arc between the equator and the parallel of latitude, either north or south of the equator. As the latitude increases, it is obvious that when that latitude is 90 degrees, it is maximum and we are at the pole. If we take a great circle plane and rotate it so that the north-south axis lies in it, we have formed, where it cuts the Earth's surface, another special great circle. It is called a meridian. Note that the planes of the meridians are perpendicular to the plane of the equator. Any great circle which passes through both poles forms a meridian. As we use the equator as an origin from which to measure the parallels, so we must establish a point of origin from which to measure the meridians. For this purpose, the meridian which passes through Greenwich, England, has been chosen as the origin. It passes through the Royal Observatory located there and is represented in the observatory by the cross wire mounted in a telescope. It is called the zero or prime meridian. The zero meridian at Greenwich is used as a basis for measurement of longitude, the other coordinate by which any position is located on the Earth's surface. Longitude is measured by the angle at the center of the Earth between the plane of the Greenwich meridian and the plane of the meridian of the observer. The longitude of a place is also the arc of the equator intercepted between the prime meridian and the meridian of the place. It is measured from the prime meridian toward the east or west through 180 degrees. It is important to note in measuring longitude that while meridians are great circles, only the half from the north to the south poles passing through the position is called the meridian of the observer. Now rotate the Earth so we are looking at the South Pole. Note how longitude increases east and west from 0 degrees to 180 degrees. These two coordinates, then, latitude and longitude, are used to locate positions on the Earth's surface. Remember, latitude is measured north and south of the equator, and longitude is measured east and west of the prime meridian. To show the practical use of latitude and longitude, we will locate some cities, approximately, by using these coordinates. Greenwich, England, we know is on the prime meridian, and therefore its longitude is 0. Following along the prime meridian to the north from the equator, we come to Greenwich at latitude 51 degrees north. The location of Greenwich is, therefore, latitude 51 degrees north, longitude 0 degrees. Returning to the equator, proceed west until the meridian through Annapolis is reached. It is in west longitude 76 1/2 degrees. Following north 39 degrees, we arrive at Annapolis. Annapolis' position, then, is latitude 39 degrees north, longitude 76 1/2 degrees west. Moving west to the meridian which passes through Honolulu, we are now in longitude 158 degrees west. Moving north, we find the city in latitude 21 degrees north. Its position, therefore, is latitude 21 degrees north, longitude 158 degrees west. Continuing further west, we reach the 180th meridian. We now enter east longitude and proceed to the meridian through Darwin. This is 131 degrees east longitude now, not west longitude as were the other cities. Moving south, we find Darwin at latitude 12 1/2 degrees south. Its position, latitude 12 1/2 degrees south, longitude 131 degrees east. Now let us see how we measure changes of position. If our first position is latitude 40 degrees north and we wish to go to 10 degrees north, we travel south and change position 30 degrees. That is to say, our difference of latitude, which is represented by the letter L, is 30 degrees. Proceeding north from latitude 10 degrees north to latitude 40 degrees north, the difference of latitude is the same. Going from latitude 10 degrees north to latitude 20 degrees south, we will also traverse 30 degrees of latitude. From latitude 10 degrees south to latitude 40 degrees south would again be 30 degrees difference of latitude, and we would have traveled south. To examine longitude, let us observe the Earth's south pole. Now, if we are at 120 degrees west longitude and headed east, traveling to 10 degrees west longitude, the difference of longitude, which is represented by the letters DLO, is 110 degrees east. When crossing the prime meridian, the longitudes are added to obtain the difference of longitude. For example, heading east from longitude 120 degrees west to longitude 10 degrees east gives us a difference of longitude of 130 degrees east. Heading west from longitude 120 degrees east to longitude 10 degrees east will give 110 degrees difference of longitude west. If, however, the 180th meridian is crossed in either direction, the actual difference of longitude traveled is not the sum of the longitudes. For example, if we go from 170 degrees east longitude to 80 degrees west longitude, we naturally would travel east across the 180th meridian, which would be the shortest distance. Therefore, the DLO would be the sum of the two longitudes, 250 degrees, subtracted from 360 degrees, which equals 110 degrees east. The reason for this, we can see, is that we would travel 10 degrees eastward to the 180th meridian, and then 100 degrees more to the eastward to reach the 80th west meridian, or a total of 110 degrees east. Thus it can be seen that with latitude, if the equator is not crossed, the smaller latitude is subtracted from the larger. If the equator is crossed, the latitudes are added to obtain the total difference of latitude. With longitude, if neither the 0 nor the 180th meridian is crossed, the smaller longitude is subtracted from the larger. If the 0 meridian is crossed, the longitudes are added to obtain the difference of longitude. However, if the 180th meridian is crossed, the longitudes are added, and this value is then subtracted from 360 degrees to obtain DLO. For measuring distances when navigating, we use the nautical mile as the unit of linear distance. A nautical mile has this length, which is the same as the length of 1 minute of arc measured along the equator. This particular unit was chosen because, for all practical purposes, it is equal to 1 minute of arc on any great circle of the Earth. Therefore, in constructing a chart, 1 nautical mile is considered to be equal to 1 minute of latitude. A nautical mile is equal to 1 minute of longitude only at the equator. To show the reason for this, observe that the angle AOB is constant, so that the 5 degrees of longitude at the equator is still 5 degrees at the pole. On the other hand, watch what happens to the distance AB. It becomes less the further we move from the equator. This distance, measured in miles, is called departure. The angle between the meridians is constant regardless of latitude, and is called difference of longitude, or DLO. It is important to remember that only at the equator does difference of longitude equal departure, and that everywhere else difference of longitude is numerically greater than departure. Up to this point, we have dealt only with changes of position which have taken place along either meridians or parallels. In other words, we have moved on a north-south or an east-west course. However, any other course may be considered to be a of motion in the north-south and east-west directions. If a ship leaves A and moves toward B, note that as it steams along its course, it is making good a certain distance northward and a certain distance eastward. The distance northward is difference of latitude, and the distance eastward is departure in miles traveled from A to B. The angular distance to the eastward between the meridian of A and the meridian of B is the difference of longitude measured in degrees and minutes of arc. To determine the direction of the course from A to B, we measure this angle from the north direction of the meridian of A to the right to the course line. If we are going from C to D, the course from the north direction of the meridian of C to the course line is 200 degrees. This, then, is the system of coordinates which has been developed for the use of navigators in charting their courses from place to place on the surface of the sea.